So I'm Jaskaran Singh Chabra. I'm graduated from BITS Pilani and in electronics and instrumentation branch. I'm currently doing the RTL and verification course under VLSI for All Institute.
Completed or repeated?
Yes, sir.
Okay. Do you have idea about the ASIC flow?
Sorry, it's
ASIC flow.
ASIC flow. So that fabrication process.
It's not a fabrication process. It's from starting like application specific, starting from design planning to
Yes, sir. Application specific integrated circuit.
yeah, there is some flow for it.
But like I don't remember currently.
No.
Sure, you can answer. Anusha, ready? Anusha, Manjura,
Sir,
turn on the camera first. First turn on the camera and answer.
Hello?
Anusha, ready? Anusha, ready? Are you there?
yes, sir.
Just turn on the camera and answer.
Sir, I didn't heard the question. I just
ASIC
joined
design
now.
flow. ASIC design flow.
ASIC flow from ASIC flow.
Yes, sir. First, we design starting from the architecture. We do the architecture by using the specifications, and we go for RTL design. In that, we develop the methodology using hardware description languages like Verilog and System Verilog and VHDL. And then we go for the digital RTL verification, design verification, which is done by the design verification engineers. After synthesis, we get a gate level netlist, and that is given to the backend engineers, where the physical design engineers will do the place and route and floor planning and static timing analysis. Then physical verification is done. After that, it goes to the GDS file is created, and it goes for the tape out and fabrication.
Okay. Is there anyone belongs to physical design? Hello? Anusha Reddy.
Hello.
You are feeding? You are belonging?
Hello.
Which which course you are taking? PD or PV?
DV, sir.
Okay. Anyone from PD here in this meeting? Okay. No one is from PD, I think.
I just asked the basics of digital electronics only, that's it.
Okay.
Yeah.
What is the difference between combinational circuit and a sequential circuit?
Combinational circuit works on the present input only. Sequential require stores something in memory, and that with present it gives output, like combination of both. And it has clock also.
Okay. Any other differences?
Like this is the
Combinational circuits do not have a memory element, while sequential circuits has a memory element in order to store the previous outputs.
So, what is a flip-flop?
A flip-flop is a bistable device which stores two values, that is a 0 and 1. It is a storage element.
Okay, what is the difference between flip-flop and the latch?
Latch is a level triggered element, and flip-flop is an edge triggered element. And latch is less prone to noise, where flip-flop is more prone to noise.
I think flip-flop is
Latch-
less prone. The flip-flop has some enable in it which prevents the noise to affect the outputs.
Yeah, one concern. Once tell again the point.
Sir, what?
Once repeat the point once. What you have said.
Like, so flip-flop has one enable connected to both the AND gates of which makes it less prone.
Okay.
And
Yes,
the
sir.
conditions which cannot be used in latch, like when both are one, both inputs are one in SR latch, that is also handled with flip-flop usage.
Okay. Okay, which latches we are mainly using in our field, like
SR latch maybe.
sir, why sir? Why?
Like it has set and reset features. You set the bit and again reset the bit.
We are mainly using the latches to store the data.
Sir, sorry, can you please repeat?
D flip-flop, D flip-flop we are using to store the data.
Yes, sir. Yes, sir. D is transparent latch type.
To give 0,
Yes, sir.
1 means 1.
Yes, sir. Both same output.
Yeah, because of same output, we use D flip-flop.
Yes, sir.
In all of the cases.
Uh, sir, I didn't get the question. Like,
Okay, which what?
So like in all of the cases means
Like for functionality, there is a RTL time will write the code now.
yes sir.
They will use like basic stuff.
Okay.
Okay. That's
Okay
okay.
sir.
You have any idea about CMOS?
CMOS is like
For what is CMOS?
it has three terminals like gate, drain, and source. And sorry, it can also be used to make the digital circuits.
That's it's like what is CMOS? Abbreviation can you tell?
Actually, I'm not able to recall that, but
Okay. CMOS is it's a combination of CMOS and NMOS. What are the operating conditions of a CMOS? What are the stages?
like saturated region, I think.
Yeah. Go ahead.
VGS should be greater than VDD minus some voltage, I think.
Yeah, starting from cutoff region.
Yes, sir, from cutoff till saturation. It works under saturation region.
Okay. Uh, there are three regions now: cutoff, triode, and saturation.
Yes, sir.
You have idea about it? Like what is the difference? How you differentiate the three regions?
Like cutoff region is the starting point after which saturation region starts, where slope is constant and slope is zero.
Yeah. Wow, okay. What is threshold voltage?
Like minimum voltage after which current starts to flow in the diode.
Current starts to flow.
In the like forward bias condition.
Okay.
Like
So what is
I need to like revise these analog electronics part.
okay?
Yeah, that's why, sir.
It's just a basic. Okay.
So like it's around 5-6 months I have left.
Yeah. Okay.
That's why, sir.
Okay. Yeah, we are using, you have an idea about enhancement MOSFET and diffuse MOSFET.
Like I have forgotten most of the things.
Mm.
These were covered during COVID time in like third year, second year.
Okay, what you have now learned in this?
Currently, I'm doing digital electronics and and started Verilog coding part.
That is very long. And very long, like RTL team will write the code in which modeling, behavioral, structural, or
Algorithmic code.
what?
Like algorithmic code is written in behavioral.
Yeah, that will.
Yes, sir.
Now you are learning the Verilog, right?
Yes, sir. Like Verilog coding.
You you have taken training for DV.
Sir, can you repeat?
DV or
The RTL
verification
verification.
verification only.
Yes, sir.
What the DV person will do? What is the job of a DV person?
Sir, DV person verifies the working of the circuit, like whether it is having working properly with the Verilog coding. All the inputs and outputs are
Yeah,
working on.
like how will they verify?
Like they will write first code, uh, behavioral code or gate level or uh, that type is also there. That code they will simulate in some software and by writing test bench and give inputs in the test bench and accordingly see the waveform generated after synthesis, whether the waveform is correct or not.
Okay, after synthesis, they will see.
Yes, sir, after synthesis.
After synthesis, we will get an uplift.
By
You know what is synthesis?
synthesis means to like see in make it in hardware form, like synthesizable.
Synthesis means what the RTL code have written, it is converted to netlist.
Yes, sir, like code is converted to hardware.
Netlist we will call as not hardware.
Okay, sir.
Like test benches, how they will create by using which language?
Sir, Verilog language only.
Very
Like
low.
like module in which they have written module, that language only.
Okay. Like you have like any idea about UVM?
No, sir, I have not studied that.
Okay. System Verilog, I think they will use for DV.
No, no idea about that also.
Okay.
Like I'm not able to recall, I think.
First, first you have to see the aspect flow and then you have to start by anything, any field in VLSI.
So can you repeat, please?
Asset flow. First, we have to see the asset flow, then start.
Yes, sir. Asset
We have
flow.
one. First, we have to see that thing. We have to start anything. Just electronics or scheme of everything.
Yes, sir.
Okay, in disk electronics, how many parts we have covered?
Sir, all parts nearly. A combinational, sequential,
Okay.
logic, gate.
Logic like what are the universal gates?
NAND gate and NOR gate.
Why and not?
Because we can make the operations of AND, OR, and NOT from them.
Which gates? We can make
Sir, AND gate, OR gate, and NOR gate, NOT gate. We can make.
only those three.
Sir, like those three are like basic requirement for universal gate.
But there
We
will
can
be
make every type of gate.
that we have to see now. XOR will be there now.
Yes, sir.
XOR. What is mux?
Sir, it is a selecting one of the input and giving it as output. So it has multiple input lines, and accordingly to like 2 per n cross 1 mux has n select lines and 1 output. So according to the combination of select lines, one of the input is taken and given to the output.
Okay. Can you make right here and get using mux?
Yes, sir, we can make.
Can you tell that how they will make?
We will take 4 cross 1 mux, 4 cross 1 mux, and 2 select lines will be there. So at the position of 1 1,
Take 4 cross 1.
or 2 cross 1 will also be fine. Like we will take no, sir, 4 cross 1 mux.
Why 4 cross 1? 2 cross is enough.
Yes, yes, sir. Yes, sir. 2 cross 1 mux will be enough.
2 cross 1 mux.
Yes, sir. Like 1 for A input,
And
and that select
can
line will
you
go to second mux input.
syndicate state table construct?
Can you repeat, please?
State table of syndicate.
Sir, A, B, like 0, 0 will give 0, 0, 1, 0. Then 1, 0 will give 0, and 1, 1 will give 1.
Then you have to, for making an syndicate using mux, how can you what are the inputs you will give and what are the selection lines you will make?
Like
Yeah, once right with
A and the other input to select line.
what?
Like at one position, we will put A input. select line is B, and on 0 position 0 will be there. Yes sir, 1 marks is enough.
Yeah. Yeah. How many marks are required? How many 2 cross 1 marks are required for 8 cross 1 mark? 8 cross 2 marks.
8 cross 2.
3.
Sir, 8 cross 2 marks is not possible.
8 cross 3. 8 cross 3.
8 cross 3. The mux has only one output, so how is it?
Yeah, that's I'm telling about the selection line.
Oh, okay, sir.
Yeah, sorry, 18 to 1 marks.
Stage will require 4, second stage will require 2, and last stage will require 1.
Okay. Okay. How many full adults, half adults are required to form the full adder?
2 half adders.
2 half adults and
Yes, sir. Yes, sir. 2 half
only
adders.
2 half adults and
And OR gate.
yeah.
Sorry, what happened?
Yeah, Rajat, it's completed.
And this also very dull interview. Take some serious question. Right? Prepare the question in advance.
Yeah, okay.
Okay, fine. Okay, just Thank you. Thank you so much.
Thank you, sir.